Okay, we're going to talk about radiation and the different types of radiation, what ionizing radiation and non-ionizing radiation is. So let's get started. We've already written this stuff down, right? There's three main types of radiation: an alpha particle, which is a helium nucleus, and it can be stopped by a sheet of paper. It's not really dangerous to humans. Your clothes stop it. It doesn't really penetrate into your skin at all. It's not a problem. There's beta particles, which are electrons or positrons. They are stopped by aluminum foil. Again, on the outside of you, it's not going to be that big of a deal, but if you remember watching the video on Compton scattering, when you get an X-ray, the X-rays can cause electrons to come out of orbit, essentially, to ionize, and those electrons within your body, or those beta particles within your body caused by the Compton scattering, can cause problems. Okay, so beta particles, not quite as big a worry. Gamma rays. This is a high energy light, low, short wavelength. Remember, they're inversely proportional. Short wavelength, high energy light can be stopped by thick concrete or lead. As you're watching the battle for Chernobyl, and you'll see them talk more about radiation, you'll have to look at the kinds of clothes that they decide to wear. Those clothes will give you an indication of the type of radiation that they expect. And we watched the miners digging under the reactor. They didn't seem to get much information about which type of radiation they should expect there, and so they didn't wear a lot of clothes. All right, so ionizing versus non-ionizing radiation. Ionizing. That means it can knock electrons out of orbit. Okay, you can think of Compton scattering. Or the photoelectric effect. So ionizing radiation has the ability to give an electron enough energy to leave its atom or molecule. Non-ionizing radiation does not have that ability. Now, why is ionizing radiation so dangerous? Well, over here, we've got the line, the boundary here, in the ultraviolet spectrum. So right here is our ultraviolet. Anything over here is ionizing radiation. This is high energy. High energy, short wavelength. Things like X-rays, gamma rays, they're ionizing. They will knock electrons out of orbit. Which is to say they give the electron enough energy for it to leave. Now, that's important because electrons are the source of chemical bonds. And when you alter the electron configuration of molecules, you can alter those molecules themselves. And DNA is one of the most important molecules in your body. It's a very large molecule with a lot of chemical bonds in it. And gamma rays can make it into the nucleus of the cell, hit the DNA, knock some of the electrons out of that DNA, damaging the chemical bonds in that DNA. When it damages that DNA, well, then that DNA might have an error in it. So when it's transcribed, you get an error in DNA transcription. Hopefully the body recognizes that there's an error in it and the cell dies. If the body doesn't necessarily recognize that there's an error in it, the body might replicate that error. And this is where you start to get cancerous tumors forming. Okay, so ionizing radiation is high energy, short wavelength, has the ability to knock electrons out of their molecules, damaging those molecules. And that can cause damage to DNA. You can see here we've got medical x-rays right here. They deal with this. Gamma rays, as we watch Battle for Chernobyl, you'll see they have to encounter gamma rays. Now, in this area between the infrared and the ultraviolet, we have the ability to excite electrons. It doesn't knock them out of orbit. It can put them into a higher orbit. It can excite the electron. If you remember talking about the photoelectric effect, or how light is made, right? Exciting electron can put them up into a higher orbit, right? We drew a diagram that looks something like this. Here's the nucleus. Here's the orbit. Here's one orbit. Here's another orbit. Here's an electron. A light ray can hit the electron, knocking it up into a higher orbit. Right, but the electron stays in orbit, just at a more excited, a higher, more energetic orbit. Okay, so visible light and infrared has the ability to excite electrons, but it's not ionizing. It will not damage the DNA. Right, so heat lamps, if you've ever seen one of those red lamps that you heat up, sometimes you heat up the chickens with, sometimes you put it in a calf shed. It produces a lot of infrared light, which makes things warm. Now over here you've got the non-ionizing radiation. Non-ionizing radiation is like microwaves, radios, well actually, all of this from here on out, that's all non-ionizing radiation. This just does not even do anything to the electrons. But in the thermal section, it will make things warm. So microwaves have the ability to make things warm. So I think it's called coherent scattering. So it's where the whole molecule just vibrates more. So you hit it with a microwave and the molecule will vibrate more. So microwaves will not damage DNA. Okay, they just make things warm. So microwave oven, you can heat things up with it. Way over here on the really long wavelengths, these guys way over here, things like radio waves, they don't even warm things up. Low frequency, long wavelengths. And so those can be caused by power lines. We've got AM radio kind of right in here. So you can see those are all types of non-ionizing radiation. They cannot hit the electrons and cause the electrons to leave their molecules. All right, so you can see here in a black body radiation, like the sun, this is the radiation that the sun produces. You can see this line kind of right here. This is the ionizing radiation. And over here, this is non-ionizing. And you can see here that the gamma rays and X-rays, the sun produces very little gamma rays and X-rays, so we don't have to worry too much about that. The ozone layer also takes care of a lot of the UV radiation. So the ozone layer blocks out a lot of the UV radiation, so it's not a big deal. It is if you stay out for a long time, you get sunburned, but the ozone layer does a pretty good job of blocking out the UV radiation. So we don't actually get a lot of ionizing radiation from the sun. Most of the radiation that we get from the sun is non-ionizing, and most of the sun's radiation is, right in the sweet spot, the visible radiations. That's what the sun produces most of, a lot of visible radiation, which allows us to see very well. And it's good that it does not produce a lot of ionizing radiation. All right, so that's the difference between ionizing and non-ionizing radiation. In the next section, we're going to talk about measuring radiation.